Alright guys, for this video, I'm going to go ahead and show you this whole question, because in case you're not quite sure how to do all these different methods, watch this and kind of see if it makes sense to you. So, in this example, we want to solve this one quadratic equation by 4 techniques: by factoring, taking square roots, the quadratic formula, and by graphing. So the first thing you need to think about is this in standard form? And in this example, this original problem is not. So before I do anything else, I need to subtract this 6x over to the left. And then it will give me x squared minus 6x minus 7 equals 0. I'm going to use this quadratic in each of my examples. This is standard form. So now I can identify my a value, which is 1, my b of negative 6, and my c of negative 7. Okay, so I'm going to first start up here with factoring. So let me copy it again. So we have x squared minus 6x minus 7 equals 0. Now in terms of factoring this quadratic, remember that we talked about 2 special cases so far that gives us some speed. So a equal to 1 is one of those. So in this case, if I can factor this, I can factor much more quickly, kind of avoiding some of the grouping steps that we'd have to use when a is not 1. So in this case, first I'll make my x factor. Up here's a times c, so 1 times negative 7 is negative 7. Then down here's my b value of negative 6. And in this case, 7 only has one factor pair of 1 and 7. Making the 7 negative, this does work. So it's factorable. So because a equals to 1, at this point I can jump right to factored form. And it's going to have this look to it. All you have to do is input the numbers you found, in this case 1 and negative 7, right into your 2 factors. And so now you've factored this quadratic, you can solve from factored form by letting each factor equal to 0. So either x plus 1 equals 0, or x minus 7 equals 0. And if I solve these little equations, I can quickly find that my 2 solutions for this quadratic are either negative 1, or if I add 7 in this equation, positive 7. So I've now found that for this quadratic, my solutions are negative 1 and 7. The goal at this point is to use these different techniques to see that if we get the same answers for the exact same question, which you should. Next here is going to be taking square roots. So let me copy the original question again. So x squared minus 6x minus 7. But guys, notice how in this case, because this quadratic has an x term, I can't use this method. So remember that to use this approach, it's limited. It doesn't always work. And so it does not work when you have an x term, because you can't solve for x by getting it by itself. So in this case, I cannot use taking square roots to solve this particular quadratic. So I'll move on. The quadratic formula. So again, let me copy the original question again. X squared minus 6x minus 7 equals 0. And so here is my a is 1, b, and c. Guys, remember that for this technique, we said first find the discriminant. So I'm going to first find b squared minus 4ac. And I'll do that here now for you. B squared minus 4ac. B here is going to be negative 6, so that'll go in there. And guys, I'm going kind of fast now because this is not new anymore. A is going to be 1, so I'll put a 1 there. And our c value is going to be negative 7, which goes there. So by inputting these values, I can find the discriminant. So I get 36 plus 28. And if I add those together, I get 64. So again, using this approach, if the discriminant is a positive number, I expect 2 solutions, which we've already found up here. Plus, if it's a perfect square, I know I can factor it, which I did already up here anyways. So this is factorable. But for this technique, I can now use the formula. So x equals negative b plus or minus the square root of the discriminant all over 2 times a. So at this point, I can now input my values. So x equals negative b, but b is negative 6. I'll put a negative 6 in here. So b equals negative 6. Plus or minus the discriminant, which you've already found to be 64. So I'll put 64 there. All over 2 times a, but a here is 1, so I'll put a 1 here. And I can work out this, I can go from here. So now I get a negative times a negative here is a positive 6. So I just use black ink, 6, plus or minus. Luckily here the square root of 64 is a perfect square, so it equals to 8. So that's kind of nice. And this will be divided by 2. If I separate these now, and let me kind of move my screen just a little bit here for some space, I get 6 plus 8 over 2 and 6 minus 8 over 2, which gives me 6 plus 8 is 14 divided by 2, 6 minus 8 is minus 2 divided by 2, and going all the way down I get 7 and negative 1. So I've now solved this same quadratic using the quadratic formula. Guys, please take a moment and compare. When we solved by factoring, we found x is negative 1 and 7. When we solved by the formula, we found x is negative 1 and 7. So you see, the result won't change, but we just have different approaches. You have to decide, given the problem that you're facing, which is the most efficient way to solve. Okay? Guys, to finish, we'll solve this by graphing. So if I'm going to graph this quadratic, guys, because of spacing, let me kind of move just here to the side. So I'll do the work here. So it's x squared minus 6x minus 7 equals 0. That's your original problem. Again, a is 1, b is negative 6. I'm just copying it each time over and over again. When we solve this quadratic in standard form, we have to first compute the vertex. So guys, remember to do that, we need to first find h. Now this is going back to first semester, so that's going to be negative b over 2a. That's how I find the h value from standard form. And so in this example, negative b is a negative 6, I'll put a negative 6 here. So negative 6 goes there, all over 2a. A here is 1. So I can quickly here compute that our h value is going to be 6 over 2, which is going to be 3. So our h value is going to be 3. Now that's part of our vertex. To find k, the other part of the vertex, I take the original equation, copy it again, so x squared minus 6x minus 7, and I can input the h that I just found into where x was at. So a 3 and a 3. And if I work this out, I get 9 minus 18 minus 7. That's just going to be minus 16. So now I found k. So guys, with all this work here, I just found the vertex to be 3 and negative 16. So I can now plot that point as, because this goes by 2, so if I zoom in, this graph goes by 2, so 3 would be 1, 2, 3, then negative 2, 4, 6, 8, 10, 12, 14, 16 right there. So I'm going to plot that point right here. Then guys, to finish this example, now what I have to do is make a table to find some additional points. So if I make a table, and again, notice how as I'm doing this work, graphing takes a lot of effort. So guys, if you think about it, if you're going to solve a quadratic, in this example, to me, factoring seems to be the quickest one. Do you see, if you compare the amount of work? Graphing is very involved. But if you guys use Desmos, you could type that in, and it can do it for you automatically. You can just then trace the graph and interpret it from there. Okay, to finish up, if I make a table, I'll put the vertex of 3, negative 16 here in the center. I'm going to choose to work with 2 and 1 to find some additional points. And so if I did that, guys, I could find g of 2. And this is obviously a lot of work here, right? You can see that as I write it on the screen. Hopefully you're still with me here. I can input a 2. Because this is not hard math, but it's just a lot of stuff. So if I work this out, I'm going to get g of 2 equals to negative 15. That's going to be the output there. And then one last time I can find g of 1. And that's going to be basically x squared minus 6x minus 7. And I'll input a 1. And I end up getting here 1 minus 6 minus 7, which is 1 minus 13, which is minus 12. So I could compute additional points and get the following. 2 minus 15 will be here. And then 1 minus 12 is going to be here. And because if I just reflect these points, I get something kind of like this. And again, if you look at where they sort of cross, they cross at negative 1 and 7. Guys, with that, if I scan back here, back to the original, we just solved one equation using, in this case, 3 different approaches. Factoring seemed to be the faster one, but the formula also gave us the same answers. And the graph, although it took a lot of time, if you look at the sketch that I gave you, you can see it does cross at negative 1 and positive 7. So you can see that all the different approaches got us to the same result.